So with this example, I'd like to demonstrate some of the algebra that you could run into, along with knowing how to prove if two functions are in fact inverses of each other. So the first part of the directions are asking us to find the inverse of the function f. So we see that below, f of x equals 8x over 3x minus 5. So we'll go through that process first. First thing I do whenever I'm finding the inverse, I rewrite f of x as a y. At this stage, I'll interchange the x with the y. So this y now becomes x, and all the x's now become y's. Now what we'll do is solve for the new y. So as we see, we have y in a couple of spots. This is a rational equation. So we'll take our time and we can multiply both sides of the equation by the LCD, which is 3y minus 5 on both sides. I'll move over just a little bit so I can fit that in. So on the left side, we have a binomial times a monomial. So we can distribute. So 3y times x, I'll just write it as 3xy. I like alphabetical order. And negative 5 times x. So that should be equal to, notice on the right side, your 3y minus 5s will divide out, and you will be left with an 8y. Now remember, our job is to solve for the y's. So what we would see is we see a y on both sides of the equation. See if I can mark it in pink. And with that y on both sides of the equation, in order for me to solve for it, I'd like to remove one of the y's from one of the sides so that I can get the y's on the same side of the equation. So to me, I think it takes a little less steps if we were to subtract 3xy from both sides. So I'm moving all the y's to the right side. So this will leave me with negative 5x equals, we don't really have like terms, so we'll just write this horizontally. I have 8y minus 3xy. Now again, notice we have y's on the same side of the equation. And whenever we don't have a case of, we are not able to combine like terms, one of the tricks we do is kind of reverse distribution, or in other words, you might know it as factoring. So I'm going to factor the y out as a GCF from the right-hand side. So if I do this, maybe I'll do it in red just to kind of make it stand out. If I were to pull the y out, I would be left with an 8 minus 3x. So that y has been factored, just so that you can kind of see what's happened. The left-hand side is still negative 5x. And us factoring out this y now makes y a factor between y times 8 minus 3x. So if we want to solve for y, we can. We can divide both sides by the binomial, 8 minus 3x. So what happens is the 8 minus 3x divides out on the right-hand side. We are left with the y. And on the left-hand side, we have another rational expression. I'll write that a little nicer for you. Negative 5x over 8 minus 3x. Now we've isolated it. We've solved for y. The very last thing, remember, we don't want to confuse the original function with our inverse. So remember this whole idea, after we switch the x's and y's, we need to rewrite y as f inverse of x. So we have negative 5x over 8 minus 3x. Now, if you're interested, sometimes it makes us feel better if we can rewrite it so that the inverse notation is on the left side. Feel free to do so. Either way, it should be correct. But I know if we're going to use this later, we want to refer to it in this manner. So that was a lot of algebra. We are still not done with the problem. We had to find the inverse of the function. So we have. Next thing we'd like to do for ourselves is we're going to have to show that f of f inverse x is equal to f inverse of f of x. And both of those statements are in fact equal to x. So what I'd like to do is I always start off with one of the versions of the compositions. So just so that we have our original function and our inverse in one spot, I can circle this for you. I see the original function. I'm going to rewrite the inverse just in case. Just write by it. So f inverse of x, remind myself what it is. Negative 5x over 8 minus 3x. Just kind of have to go through this. Now I'm going to start off with f of f inverse x and try to understand what this means. So f of f inverse x, what I'm looking at is understanding who's the inside function and who's the outside function. So remember, the outside function is always the function that's referred to first. So it's like the outside. And then the inside is the one that's referred to second. And once I can kind of relate this to outside versus inside, I can rewrite this statement so that it's a little bit nicer for me to work with the mathematics behind it. So f of f inverse x is the same thing if we write the f on the outside and the f inverse of x on the inside. So that's a little bit more usable to me in this sense, because now I'm going to take my f inverse x and replace it with its actual formula. So we have f inverse x. We had just found it to be negative 5x over 8 minus 3x. And what we're going to be doing is plugging that in to the f of x function. Okay, so a little separate work, so I'll draw a line. So f of negative 5x over 8 minus 3x is notation to tell us to, and I don't know if, I might as well write it in English. We're actually plugging in negative 5x over 8 minus 3x. Plug this into the f of x function wherever we see x. Okay, so remind ourselves what f of x is. We're finding f of negative 5x over 8 minus 3x. So what this looks like, I'm going to take the format of the f of x. So I should have an 8 times x, that's something, over 3 times something minus 5. So that's it. We're looking back at the f of x function, 8x over 3x minus 5. I use parentheses because what I now have to do is take this argument and plug this in wherever I saw the x. So I'll do that for ourselves. Negative 5x over 8 minus 3x in both places. So now what we have the function composed with its inverse. The issue now is we're going to have to simplify. So we have ourselves a complex fraction, by the way. So kind of keep in mind all the techniques we've played with in our past math courses. We're going to have to be able to simplify this. Maybe for now, what I'd like to do is I do see that I have a monomial 8 times a fraction. So that's like 8 over 1 times negative 5x over 8 minus 3x. I may just understand multiplying the numerators, might be a little nicer. So this numerator would be negative 40x, that's 8 times 5, over 8 minus 3x. Cleans it up just a little bit. And same idea with the 3. So we have 3 over 1 times negative 5x times 8 minus 3x. So that will leave me with negative 15x over 8 minus 3x. Still subtracting off the 5. We couldn't do anything for that. So still, that didn't help much in terms of the fact that you still have a complex fraction, but it did clean it up a little bit so that we can now kind of approach what we want to do. Now there's a couple of methods that we turn to whenever we want to simplify a complex fraction. I personally like multiplying the numerator and denominator by the LCD of all of the fractions that we see. So if we're kind of looking at fractions, we have one fraction, whoops, I don't want to cross that out, I want to highlight it. We had one fraction on top, still not working for me. There we go. So we have this fraction on top, that's 1. Fraction on the bottom, 2. And we have a integer on the bottom as well, that's 3. Because technically, you can write that 5 over 1. So you have 3 fractions. What we're going to do is multiply the numerator and denominator by the LCD. In our case, the LCD is the only denominator we see other than a 1, which is 8 minus 3x. So if we were to do this, we'll take a little time. I have 8 minus 3x. I'll go in the front for you. So that's multiplied to the numerator. And 8 minus 3x is multiplied to the denominator. We'll take a few more steps. I know there's some shortcuts we can take, but don't skip because we want things to come out a little nicer. More of a chance if you skip steps, you might miss something. So I'll take it a little slower. Notice in the numerator, you have 8 minus 3x will divide out. So your new numerator will be just a negative 40x. This makes us happy. The 8 minus 3x in the denominator has to be distributed to both of the terms. So let me see if I can use orange to help us out. Now, if this happens, when I do this, I'm going to write out an extra step just in case. I have 8 minus 3x. That gets distributed to the negative 15x over 8 minus 3x. Then I have a minus sign. 8 minus 3x gets distributed to the 5. I'm taking time to write out this step, mainly because I want you to see what happens to the 8 minus 3x when we multiply it to that fraction in the denominator. So I'm rewriting negative 40x on top. Check out what happens to the 8 minus 3x. Remember that LCD is always written over 1, and then the 8 minus 3x will divide out. So we will just be left with a negative 15x. And now what has to happen is we're going to distribute that 5 to the 8 minus 3x. And there's more than one way to do it. I'll just take a little time on this. Keeping in mind that there is a minus sign in front of everyone. So we have 5 times 8 is 40, and 5 times negative 3x is negative 15x. So now we no longer have a complex fraction. We just have to simplify the denominator a little bit more. I still have negative 40x over 15x with a negative in front of it. And at this point, we are distributing the negative sign. So we have negative 40 and then plus a 15x. So if we take our time and combine like terms in the denominator, you will see that the 15x's neutralize. You will get negative 40x over negative 40. And then what happens to the negative 40 over 40? They divide out, and we are left with just an x. So what does that mean? We have just shown that f of f inverse x equals x. So you started off with f of f inverse x, and you ended up with the x. So that's part of your proof. So just so that we know. So f of f inverse x equals x. That's one of it. Now, we took care of the purple part. We need to take care of the teal part. We got to go backwards and show this. So a little exercise there with the algebra. Pretty much the same thing. We're just kind of using this backwards. So I'm going to look at the teal part. F inverse of f of x. Okay, and so we kind of remind ourselves if we're rewriting this, let's do that composition symbol a little bit more accurately. This time, our outside function is the f inverse. Our inside function is the f. So if I want to rewrite it for myself, I would like to see it as f inverse on the outside, f of x on the inside. We'll now take this notation and keep in mind that we're going to be replacing f of x with its formula. So I got to go back and look at it a little bit. That is 8x over 3x minus 5. Write that a little nicer. And what we'll be doing in terms of what we're trying to do, let me draw a line to separate our work. We now have notation that we'll be taking the 8x over 3x minus 5, and we're going to plug this into the inverse wherever we see x. So that's notation. Plug in 8x over 3x minus 5 to the inverse wherever, probably not spelling wherever right, I think it's two separate words, we see x. So as a kind of a notation for you, let me kind of draw it off to the side just so that we can see this a little better. I'm going to remind myself what the inverse function was at negative 5x over 8 minus 3x. So just kind of a little bit note. Let me make sure I wrote that down correctly. There we go. So sometimes I like to just refer to it off to the side. That way, if my eyes don't skip, I miss anything. So what this means, everywhere I see x, I'm going to be replacing 8x over 3x minus 5. We're going to take our time a little bit. So f inverse, like the skeleton of this function, we like to say, or the bones, negative 5 times something, that's the x, over 8 minus 3 times something. That something happens to be what we'll need to plug in, the 8x over 3x minus 5. Two places. So wherever we see the x. So now you'll notice again, we have ourselves a complex fraction. And it's the same story as what we did in the previous part. We just get something slightly a little different in the numerator and denominator because we compose these functions backwards. F inverse composing with f this time around. So I'll kind of approach it the same way. I will notice for myself, I still have this big complex fraction bar, that this negative 5 is a single term or factor. So I'll take it where I'm multiplying this by the numerator. So that gives me also negative 40x on top. And on the bottom, we get 3x minus 5. A little nicer version. We still have 8 in the denominator. But when we multiply the negative 3, again, that's also over 1. We would get minus 3 times 8x is 24x, all over 3x minus 5. So at this stage, we still have a complex fraction, but it's looking a little less complicated. I will now take the LCD that I see, kind of keeping in mind this 8 is an integer, so you can write it over 1. The LCD that I see, the only denominator other than 1 is 3x minus 5. So I'm going to multiply 3x minus 5 to the numerator and the denominator. And you're kind of doing this where it's over 1. Kind of keep this in mind. So if we do this to the numerator, the 3x minus 5s divide out. That's nice. In the numerator, we will get negative 40x. And if I'm do this over here, I should have 3x minus 5 times 8. That is a binomial times a monomial. So keep in mind, we're distributing this to both of the terms. I'll take a liberty of a minor shortcut here because we saw kind of the idea on the last part of the example. 3x minus 5 times 8, that's distributing the 8 to both of those terms. I should get 24x, that's 8 times 3x, minus 40, 8 times 5. And now the 3x minus 5 times the fraction, the 3x minus 5s will divide out, so we'll get negative or minus 24x. So now, all we do is combine like terms in the denominator. Looks like the 24x's are neutralizing, so we have negative 40x over negative 40. Nice. And what happens to the 40s? They also divide out as well. So we are left with an x. And that's exactly what we wanted to show. Just reminding ourselves, we showed that f inverse of f of x equals x. So just so that you know. So when you go back and look, what have I done? I've shown it both ways. If I showed that the highlighted purple part is equal to x, like we did on this left side, a little bit of algebra. And I also showed that the teal part, when I compose it with the function f inverse of f, is also equal to x on the right side over here. We have just proved that the functions are inverses of each other. So this is quite an interesting example. There's a lot of algebra involved. I really, really think it's important to understand function notation and composition notation. If you get the hang of that, then it tells you what to do with the functions. So hopefully you're going to get a little practice before you dive into an example like this. You'll have a little bit more of experience, but I did want to create a video for you so that you had something to refer to when it got to these complex rational expressions. So I hope this helps. I'll see you in the next section.